Hello everybody, my name is John Sefton and I have a hypothesis that I am trying on with the various questions out there like dark matter and things like that, gravity. And so I'm going to try to explain one thing at a time. Last time out I was explaining dark matter. So this time I want to try to explain asymmetric galactic rotation curves and what they mean and how my hypothesis explains them. Like there is no, I haven't heard an explanation from them except they throw dark matter at everything. How does that work? Dark matter, you know. So that's the only explanation that I've heard. But asymmetric GRCs, when they first discovered that the outer stars were going faster, they got a flat GRC. And everybody totally lost their minds and they decided that it must be dark matter. Of course, they started checking, you know, from every other direction that they could, because they could start to, that was when they started to measure how fast stars were going using radio telescopes, I think, the very large array and things like that. And so they were able to see how fast all these stars were going. So they checked the GRCs every which direction. Because when they found that those outer stars were going so fast, I mean, they just checked every which direction. And what they found was, if you take a GRC one direction, and then you take it exactly the opposite direction, they should be the same, but they're not. When they measure the star's velocities for this one, they're going faster than the stars for this GRC. And they've checked that for every facing galaxy that they can. And that's what happens every time, and it's called asymmetric or asymmetrical GRCs, galactic rotation curves. So we've got scientists saying that, oh well, the stars on one side are just going faster than the stars on the other side. I mean, no, I don't think so. That's just, if you've got a turning circle and you think one half is going a different speed than the other half, well, I don't know, it's going to be pretty weird. But what they found was, to get a GRC for any particular galaxy, they had to average these two GRCs that are opposed to each other. And if they take that average, wherever they take those two from, they'll always get the same average for any particular galaxy. So that's the GRC for the galaxy. But you have to average the two, okay? Because one side appears to be going faster than the other side. So why is that? Well, in my hypothesis that galaxies and atoms are exactly the same thing, what that means is that our disc-shaped galaxy must equate to a sphere-shaped atom. So what that means is that the disk must be revolving through a spherical space in order to accomplish that. But I mean, if you really look at galaxies, they're not disks. They've got a spherical gas body, and they've got halos, what they call halos, and it's a double layer, a double spherical layer of nested halos of old globular clusters and gas around each galaxy. So you've got a double sphere of clusters and gas. And you've also got the gas body, which actually stretches out another third of the distance past these halos. So that's what they're seeing with the Andromeda right now. They see a double layered spherical nested halo structure where one layer of the stars is going one direction and then the interior layer is going the other direction, right? So they're having a lot of trouble explaining that. But if you think that those disks have to be turning through the spherical volume twice every time they rotate once, as my model suggests, then you'll have the disk edge coming through the spherical space going one way one time, and then the next time it comes through the spherical space it'll be going the other way. So you'll get a layer of stars, clusters, trailed off going one direction, and then the next time it comes through you'll get a layer inside that going the other direction. And so that's how you're getting those nested spherical structures in these galaxies, is because the disk is spinning like a coin on a table. So when they're looking at these facing galaxies and they're seeing how fast the stars on this side are going, and they're seeing that they're going faster than the stars on that side, all that's happening is that the disk is precessing, and the side where it's coming towards you, it looks like they're going one direction, and the side that is going the other direction, it looks like, I don't know how does that work. The side that would be coming towards you of stars would have their waves blue shifted, and the side going away would have their waves red shifted. So it's because the disk is swinging in that way that one side looks like it's going a different speed than the other side, and that's how you get those asymmetric GRCs according to the galaxy model for the atom, which is a hypothesis. And I'm just using this hypothesis to try to see if it explains things like asymmetric GRCs. So have a good evening. Thanks so much for listening.